This is Geometry, Unit 6. This is our second day on coordinate proofs. We're going to keep working with the midpoint, the distance, and the slope to prove properties of polygons. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. A parallelogram has opposite sides parallel. We see that in our picture here, and it's denoted by the arrows. When you have arrows inside the segment, that tells you that those two are parallel to each other. Two sets of arrows are parallel to themselves. We have a symbol that represents parallelogram. We have a symbol that represents triangle, but we don't have a symbol that's going to represent square or rectangle. It's only parallelogram or a triangle. So in parallelogram PQRS, we have two sides parallel. PQ is parallel to SR. This is an R over here. And we also know that QR is parallel to PS. So we have two sets of parallel sides, and that's the definition of a parallelogram. There's lots of other properties of parallelograms. So we're going to assign coordinates to our parallelogram. We, of course, have this in standard position. So we have a point at 0, 0, a vertex here at 0, 0. We're going to have another vertex out here at A, 0. Now, when we look at our third point out here, we see kind of this triangle has been formed. And this triangle is telling you that we have moved over a certain amount, and we've also moved up a certain amount. We have to think about, does it matter for a parallelogram? Or could this be at a different slant and still be a parallelogram? So we can be over any amount. It's not related to the A at all. And we can be up any amount. It's not related to the A or the B at all. But when we come over to Y, we see that we have this triangle, and this triangle has to be the same triangle as what we had over here. So if this is the length of A from W to Z, and we have to go this much more, the question is, how much more is that to get underneath the Y? Well, it's supposed to be the same as this. And that's going to be the distance of B. So this coordinate is called A, because that's the length it takes on the parallelogram, plus the B is the extra little bit. And of course, the height, the Y value, is the same because they're supposed to be parallel to a slope of 0. So those would be our coordinates for a parallelogram. So now we're going to write a coordinate proof to show the following properties. Prove both pairs of opposite sides are congruent. So you got to remember, to show sides are congruent, we're going to use a distance formula. To show congruent sides, used distance formula. Both pairs of opposite sides are congruent. So we're going to start out with Wx. And we're going to do the distance formula. I'll zoom in here a little bit. You can still use the coordinates from your picture. From W to X, we'll call this X2 and this Y2. We'll call this X1 and Y1. So we have b minus 0, and we square it for our x's, and c minus 0 for our y's. B minus 0 is just b minus nothing, squared. So it's b squared, and c squared. We cannot simplify that any further. Because of the plus, we cannot take the square root of the b squared or c squared. If there was no plus there and it was just c squared, you could take the square root of that. But you cannot take the square root if there's a plus. So we're going to compare that with yz. Well, yz will come over here. This would be our x2 and our y2 and our x1 and our y1. I like to call the bigger numbers the 2's and the smaller numbers the 1's, but it wouldn't matter. Order won't matter. It'll all work out. When you square a negative, you'll get a positive. So we say a plus b minus a, and we're going to square that, and then we're going to say c minus 0. So we have an apple plus a banana minus an apple. A plus b minus a. That means the a's cross off and you're left with just b. This is just b squared. And this is c minus nothing. So that's just c squared. Notice how these are exactly the same. So I know that wx is congruent to yz. And then we can come on over and we can show, because we're supposed to do it for both pairs. Both pairs. That was one pair. Now we have another pair to do, the top and the bottom. So let's do the top. The bottom's going to be super simple. So the top is xy, and we're going to look at our x values, a plus b, minus our x value, and our c minus c squared. That came from these points here, a plus b minus b, subtract the x's, and c minus c, subtract the y's. So a plus b minus b, that means the b's cross off. We're left with a squared plus nothing squared. Well, that's just a squared. And can you take the square root of something squared? The square root of something squared is that value. So think about it as the square root of 3 squared. It's just 3. So the square root of a squared is just a. Then to look at the other length, we can do this probably without the distance formula. WZ, it goes from 0 all the way out to A, so it's a length of A. You could plug that in the distance formula also. So we know that XY, segment XY, is congruent to WZ. So we showed 2 sets of sides congruent. And that's done. Next, we're supposed to show the diagonals bisect each other. So think about what that word means. Once you understand what to do, you'll be good.
How does a squared like go to a?
Prove the diagonals bisect each other. For them to bisect, we're going to show that they have the same midpoint. Show both diagonals have the same midpoint. So I'm going to do the midpoint of WY. Remember, a diagonal goes through the inside of the shape. Diagonal goes to the inside. It has a midpoint. I'm going to figure out what that midpoint is. Then when I do the other diagonal, it's going to have the same midpoint. So my midpoint formula are my x values added together, divided by 2, and my y values added together, divided by 2. So that leaves me with a plus b divided by 2 and c divided by 2. So that's my midpoint of segment WY. Now I'm also going to find my midpoint of XZ. That is my x values added together divided by 2 and my y values added together divided by 2. That's a plus b divided by 2 and c divided by 2. Two segments with the same midpoint shows they bisect each other. We showed both segments have the same midpoint. That means they cut each other in half. They cross at the midpoint. They share that location. They both touch that spot. And then we're going to come down and we're going to show the lengths of the diagonals. What are we going to do, or what's going to happen when we look at the diagonal lengths? Remember what diagonals are. They go through the shape to a different vertex. Not the edges, but through the shape. So we're going to look at YW. So we take our x value minus our x value, and our y value minus our y value. That's going to give us our a plus b squared and our c squared. We really can't condense that anymore. We could multiply this all out. This is not a squared plus b squared. You'd have to write it twice and FOIL it. It's not going to simplify it all. So that's the best we can do. And we're going to compare that with the other diagonal, which is xz. The xz length is a minus b quantity squared and 0 minus c quantity squared. So that's a minus b squared and c squared. Look, they're similar to each other, but they're not the same. Look at the a plus b and a minus b. They're a little bit different. Diagonals in a parallelogram are not always congruent. They're not always congruent. On our last question we have back here, we're going to assign coordinates to our rectangle. We're going to show it's a parallelogram by looking at slopes, and then we're going to show the diagonals are congruent by looking at distance. So we have a and 0 because that's the distance of z. We have b and c because, oh, actually 0b, sorry. 0b because it's 0 right and left and a distance up. So this is going to be a comma b out there. So for us to show that we have a parallelogram, we're going to show opposite sides are parallel, which is the same slope. So for xw, we do the y over the x, which is b over 0, which is undefined. And for yz, we get the same idea, which is still undefined. So two slopes that are undefined are parallel. So we know that xw is parallel to yz. xy is going to be the y values minus the x values, and 0 minus 0. Both those slopes are 0. So those slopes are parallel to each other. Then the last thing we have to look at is our diagonals are congruent. So we're going to use the distance formula for congruent. So a minus 0 and 0 minus b. That gives us a squared plus b squared. When you square a negative, you just get that positive. And what's cool about a rectangle are the diagonals are congruent. A minus 0 and b minus 0 gives you a squared plus b squared. These are the same. xz is congruent to yw.